All right, Owls, this is Mr. O with the first set of flip notes for the new wave energy unit. We're going to start off with a little bit of vocab. The first part of this unit is pretty heavy. You have to understand the basics of what a wave is, and then you have to figure out there's two different types of waves, and you need to know the parts of those waves and what they mean and what they represent. So in your waves TOC, this is going to be page number 2. It's going to be called Wave Key Vocabulary. First, we got to talk about what a wave is in general. So a lot of people can misconstrue waves with energy. However, waves transfer energy. Energy is also known as a disturbance, not matter from one place to another. So I always look at waves as if it's like a car, and the energy gets in the car and transfers from one place to another. A lot of people think waves transfer matter, meaning anything solid, liquid, gas, from one thing to another, but it does not. It transfers energy, not matter, from one place to another. Waves can use a medium. A medium is any kind of matter that waves travel through. So any type of matter you can think of can be a form of a medium. So a medium is a very big category, and with that, you have to look at the idea of if it's matter, it's a medium. Now we're going to start with the two types of waves. Now people often get confused between two types of waves, and then there's just two types of wave movements. Big differences there. So these are going to be the two different types of waves. So all waves in the world can either be one or the other. They cannot be both. The first type is mechanical. This is one of the two types of waves. The waves transfer energy through matter. So mechanical waves need matter. And that'd be the last thing. They need a medium. Remember, mediums are any type of matter. Without a medium, mechanical waves do not exist. So this is one of the two types. They transfer energy through matter, and they need a medium. No medium, not a mechanical wave. The other type of wave is known as an electromagnetic wave, also known as EM. Either way you want to refer to it is fine. This is one of the two types of waves, not wave movements. These transfer energy through a field or empty space. So they don't need a medium, but they can use one. They do not need a medium, but they can use one. So they're the type of wave that can do with or without matter. And there are 7 types. And those 7 are radio, microwave, infrared, visible light, ultraviolet, also known as UV, X-ray, and gamma. A lot of these types you've probably heard of before. So you will need to know the 7 types. You will need to know an order, but we will get more into the electromagnetic spectrum, which is the 7 types, later. But in general, right now, you just need to know there's 7 types of them as we move forward. Like I said, there's 2 types of waves, but there's also 2 types of wave movements. People often misinterpret between the two. So the movement is just how the wave looks or how it acts. So the first one will be a transverse wave. This is one of the 2 types of wave movements. This wave movement, the energy travels perpendicular to the direction of the wave. Yes, we are bringing math into this. The energy will go up and down. Envision a string in your head moving up and down. And both mechanical and EM waves can move this way. However, all EM waves travel as transverse movements. So some mechanical waves travel as transverse. However, all EM waves travel as a transverse wave. The other type of wave movement is known as a longitudinal or a compressional wave. This is the other type of wave movement. This wave movement, the energy travels the same direction as the wave. However, like transverse, the energy goes up and down as it's moving towards something. This one, the energy is going along with it. Unlike transverse, this is only found with mechanical waves. So EM waves do not travel as longitudinal or compressional waves. So remember, 2 types of waves, 2 different types of wave movements. Keep those in mind. That's why I made big headings on your notes that you're filling out today. There are parts of transverse waves that are only found there. You remember, like I said before, you have to know the different types of waves, the different types of wave movements, which means how they look or how they act, and then you have to be able to label them. Here are the labels that will come along with them. The first one, that's only in transverse waves, is known as the crest. This is part of a transverse wave movement, and by definition, it's the highest point or peak of the wave. So as high as the energy can get, That's the crest, like a crest of a mountain is the top of the mountain. The other part that is found in transverse wave movement only is the trough. Okay, just like a pig trough, it is the lowest part or valley of the wave. So this is the lowest part of valley of a wave. Crest and trough are only found in transverse wave movements, and we will discuss them more when we start to draw and label waves. There's also parts that are only found in compressional waves or longitudinal waves, the first of which is in its name. It's known as compression. This is part of longitudinal waves only, and this is the part of the wave that is compressed or closer together. Hence compression. Compression means to press together, just like its name. And in these waves, it's also known as the amplitude. We will talk about this more when we're labeling the waves. The other part of the wave for longitudinal that's only found there would be rarefaction. Rarefaction is a part of longitudinal waves only. It's the part of the wave that is stretched, extended, or expanded out. It's the opposite of compression. It's not pushed together, it's released out. And what it's showing is the release of energy in a wave. Now, we're going to go talk about the parts that you'll find in both longitudinal and transverse wave movements. First of which is amplitude. You can find these in both of the wave movements. In transverse wave, it's the distance from the resting line of the wave to either the crest or the trough. How high or low that wave goes is known as the amplitude. Amplitude, if you don't know, also means how much power the wave has. And in a longitudinal wave, it's the measurement of one full compression. When we draw these waves together, we will explain more what they mean. Next thing you can find in both types of wave movements is known as a wavelength. You can find them in both movements. In a transverse wave, it's the distance from one crest to the very next crest or one trough to the very next trough, both of which are the exact same distance. However, in a longitudinal wave, it's the measurement of one compression and rarefaction together. It's the beginning of the compression to the end of the next rarefaction. We will talk more about this when we label waves in class. Last word, I think we're nearing the end. Frequency is something that's found in both wavelengths. And this is the number of wavelengths that pass a given period of time, usually 1 second, usually. You can have high frequency waves and low frequency waves. The higher it is, the more it's happening. The lower it is, the less it's happening. It's just the word frequency, just the way it means in everyday life. Frequency and wavelength are directly related, and what I mean by that is the next bullet. As one goes up, the other one goes down, meaning if it's a high frequency wave, you have short wavelengths. If it's a low frequency wave, you have long wavelengths. We'll talk more about this as we label. And this is also used for both transverse and longitudinal. These are your key vocab. They will be set up when we start to label and start talking about waves. These are the words you're going to have to understand in the first part of this unit. So we will talk more. If you have any questions, please write them down, and I'll be happy to answer them as we discuss them in our next class.